When it comes to picking and buying cams, there is the chicken and the egg problem. Individual valve events are the only thing your engine cares about, but cams are sold by duration, lobe separation, and cam advance. Summit Racing Cam Timing Calculator helps you think like your engine. You'll see how the specific timing events create duration, lobe centers, lobe separation, advance, and overlap, not the other way around. Let's take a look at each of the 4 events so we know how they change engine behavior. Most of us know the 4 strokes of an engine. When looking at cam timing, we actually start near the end of the power stroke. Let's take a look at this graphic to give us a better visual of what's going on. First, we'll go over exhaust valve opening. At this point on the power stroke, the piston is over halfway down the cylinder. There is little positive pressure on the piston left to create horsepower, so we crack the exhaust valve open at roughly 60 degrees before bottom dead center in this example. You'll see most street strip cams start to open at 40 to 65 degrees at 50 thousandths before bottom dead center. Opening the exhaust a little earlier or later is a slight compromise. Earlier means positive pressure is no longer working to push the piston down. On the other hand, any positive pressure on top of the piston after bottom dead center is costing you power because the piston is pushing back against the crank rotation. This is called a pumping loss. By bottom dead center, most of the residual pressure has blasted out on its own. The piston starts to push out what little that is left. Of all the events, exhaust opening is the least critical because it's assisted by the residual cylinder pressure. Next, we'll cover 2 of the events at once. They will be intake valve opening and exhaust valve closing, overlap at the beginning of the intake stroke. Near the end of the exhaust stroke, the piston is nearing top dead center. The intake valve is starting to open and the exhaust hasn't quite closed. This is called overlap. In this example, we have the exhaust closing 15 degrees after top dead center and the intake opening 15 degrees before top dead center. This creates 30 degrees of overlap. Any residual exhaust pressure wants to backflow into the relative vacuum of the intake port. These burnt gases are not just what's left in the cylinder. They can also re-enter from the exhaust port, especially under part throttle. This is called reversion, and here's why it's bad. First, burnt mixture is taking up the space of fresh incoming mixture. It won't burn again, and power is lost. The second is rough running. Carbureted engines suffer more than injected engines because they rely on pressure differential to flow fuel. The third downside is sending unburned fuel out the exhaust at wide open throttle, which is wasted energy. So what's good about overlap? With tuned intake and exhaust runners and at wide open throttle, we can carry more exhaust gases out. Also, the more the intake valve is open before top dead center, the more air it will flow on the piston's downstroke. Now you know why cams with a lot of duration and overlap make big power up top, but suffer drivability. Here's a few more generalities we recognize. Headers and free-flowing exhausts show the biggest gains with larger cams. A standard exhaust system may have up to 10 pounds of back pressure at rubline under wide open throttle. A free-flowing exhaust will have less than 1 pound, and this reduces the effects of reversion by keeping flow going the right direction. A turbocharger is even less tolerant of overlap because back pressure may be as high as 3 to 1. In other words, you may have 30 pounds of back pressure for every 10 pounds of boost. This exaggerates reversion and the reason turbocams have minimal overlap. Nitrous adds exhaust volume. The engine is more susceptible to pumping losses, so we open the exhaust valve earlier. This is seen as an increase in exhaust duration. Supercharged engines are less prone to reversion at wide open throttle, but more prone to knock. Adding intake duration helps on both fronts. Next, let's talk about the period right after overlap on the intake stroke. The intake valve is open and the piston is moving down the cylinder and hitting max velocity around 73 degrees after top dead center. At the end of the intake stroke, the piston is at bottom dead center and starts to move upwards. Finally, we come to intake valve closing at the beginning of the compression stroke. After bottom dead center on the compression stroke, pressure won't start building until the intake valve is completely closed. Closing the intake valve earlier increases effective volume and compression ratio. This increases low-end torque and makes power earlier in the power band. By closing the intake valve later, we can take advantage of the cylinder head's velocity at high RPM. We trap more air, and this results in more horsepower higher in the power band. The valves are closed for most of the compression stroke and power stroke until the exhaust valve begins to open and we start all over again. Now that you've seen the importance of individual timing events, go to summitracing.com and check out the Summit Cam Timing Calculator and links for more information. Thanks for joining us today.